Imagine that you live in North America, and one day you call up your friend in Norway up by the North Pole. You guys are talking and you make plans to go visit him next summer.
So, anytime next summer works for you?
Yep, anytime is good for me.
Okay, how about June? That's summer for you, right?
Of course.
In a few months, June rolls around and you hop on a plane for your Norwegian vacation. You guys are hanging out one night when he says,
I think I'm going to head to bed.
and you say,
Come on, man, the sun's still up. You can't go to sleep.
and your friend's like,
But it's midnight.
What? I don't get this. Why is the sun still up in the middle of the night here in Norway?
that's a great question. I think we can help you out with that. If we take a look at the Earth's orbit from the side, we see that the Earth revolves around the Sun in this orbital plane once every year. Remember that Earth is tilted at an angle of 23.5 degrees, and it's rotating on its axis once every day. At this point in the Earth's revolution, the southern hemisphere is at its maximum inclination towards the Sun. This is called the December solstice. At this point in the Earth's revolution, the northern hemisphere is at its maximum inclination towards the Sun. This is called the June solstice. Let's put a line through the Earth that's perpendicular to the orbital plane. We know that this angle here is 23.5 degrees. That means that this angle here, between our vertical line and the equator, is 90 minus 23.5 degrees. That's 66.5 degrees. We can draw a circle around the Earth at the point where the line perpendicular to the orbital plane touches the Earth's surface. This circle is 66.5 degrees of latitude north of the equator.
Wait, latitude? What's that?
Latitude is a measure of how far north or south you are from the Earth's equator. If you're 0 degrees, then you're right here on the equator. If you're 90 degrees north or south, you're on one of the poles. And if you're 66.5 degrees north, like we just talked about, you're at what's called the Arctic Circle. We can do the same thing on the southern hemisphere. We draw a circle at 66.5 degrees south. This is called the Antarctic Circle.
Okay, but how does that keep the sun from setting during the summer in Norway?
I think it's best if we explain this through an experiment. Here we have a globe of the Earth, tilted at about 23.5 degrees. And we're using a flashlight to simulate the sun. We're wondering about summer in Norway, so we have the northern hemisphere tilted towards our flashlight sun. I don't think that flashlight is powerful enough for this experiment. Yeah, there we go. We can see that the half of the Earth that's facing the sun is lit up. It's daytime on this half and nighttime on the other half. We'll put a little flag here on the northern part of Norway, which is above the Arctic Circle. And we'll put another little flag here in the US, which is below the Arctic Circle. If we start rotating the globe, we see that there's a point where the sun is no longer shining on the US. We experience this as sunset. However, the sun continues to shine on Norway. It's so far north that it's always in sunlight.
Oh, awesome! That's so cool! 24 hours of sunlight! So much time for fun stuff. Skiing, hiking, mini golf.
Not in the winter.
What do you mean?
Let's take a look at Norway in the winter. During this season, the northern hemisphere is tilted away from the sun. So, if we rotate the Earth, we see that the US is in periods of sunlight and darkness. But we can't see the Norwegian flag at all. That means
24 hours of darkness.
sad, but true.
Oh man, that stinks.
It sure does.
The same thing happens between the Antarctic Circle and the South Pole, too. During their summer, they have 24 hours of sunlight, and during their winter, they have 24 hours of darkness.
That's crazy.
Even if you don't live far north or south, the tilt of the Earth still affects the length of the day. If it's the June solstice, we have 24 hours of sunlight here above the Arctic Circle, and 24 hours of darkness here below the Antarctic Circle.
Huh.
So, if we were to go a little south to the US, between the equator and the Arctic Circle, how many hours of daylight do you think we'll have?
Less than 24.
Right! It's the longest day of the year in the northern hemisphere. If we continue south until we get to the equator, halfway between the poles, here we have 12 hours of light and 12 hours of darkness. If we go even further south to Australia, between the equator and the Antarctic Circle, How many hours of daylight will we have?
Less than 12.
Exactly! This is the shortest day of the year in the southern hemisphere. The effect is reversed during the December solstice. There's more than 12 hours of daylight below the equator, and less than 12 hours of daylight above it. So, now you know how the tilt of the Earth causes both the seasons and the length of the day to change.
So it's the tilt of the Earth that gives us longer days in summer and shorter days in winter.
Right.
Awesome. I think it's time for some celebratory summer midnight mini golf, right, Martin? Martin? Martin, are you awake?